are going to, like, I just want to do like one question similar to what we did yesterday. I'll be the first one to say, like, well, I know I always tell the time, like, oh, it's not that hard, but like, this is one topic I'm gonna say, like, hey, it's kind of hard because just the types of things they can ask you. Again, any type of word problem that has like any sort of like things coming in and things leaving, we can write and look at using both derivatives and integrals, which I think is what makes some of these problems a little bit more complicated. Did want to do one today. This is not an actual AP question. I did base it off of an AP question, but I just want to kind of show you we didn't do one yesterday where we actually used the calculator to find those numbers. So I did want to do this one, and I wrote this one just to kind of give you an idea of like what a single question on the AP exam would look like. So this one does have 4 parts to it, which is what most response questions on the AP exam has. We'll see some of the AP exam, like it starts off like pretty chill, pretty easy, and then we get to like part D, and we have to like say, whoa, and it's going to take a little bit longer to do. This one is going to be a calculator required one, so go ahead and make sure your calculator is in radians. I am going to show you some tricks in the calculator, like starting with this unit, and then even more so next unit. We're going to be using our graphing calculators more and more. Like we're going to start seeing problems that we just can't do by hand, and we'll have to be able to do these in the calculator. So I'm going to show you just some tricks in the calculator that you may or may not know about. So looking at this one, let's go ahead and just kind of talk about the problem. Again, I think the first 3 parts of this one are pretty straightforward. Part D is a little bit more complicated. So looking at this, we have a haunted house. In these problems, they usually are set up in kind of the same format, like of what you've been provided and what you're trying to find. When we're looking at this problem, it tells us that a haunted house, it is opening at t is equal to 6. So that's kind of like the starting point. People are entering the haunted house at a rate. So this equation is representing a rate. It gives us the unit of measurement and the interval for when that function is valid. It does give us an initial condition at t is equal to 0. No one is inside, so we do have an initial condition of 0. And then we have another function that picks up at t is equal to 7 when people start to leave. And that function is just a constant rate of 110 people per hour. So like there's 2 functions here. We have like the rate in, which is E of t, the rate out, which is a constant function of 110 people per hour. So when we're answering these, again, we're actually going to find the values. For my class and the AP exam, you always want to show like the setup, and then you want to show the answer. The first one I think is pretty straightforward. We have how many people enter the haunted house from t is equal to 6 to t is equal to 7. Round your answer to the nearest whole number. Well, we know in calculus, if we have a rate, the integral of a rate is going to give us an amount. So how many people are entering? We do have this function E of t, which we know is the rate that things are happening at. If we integrate that, it is going to give us an amount. Well, we're going to start at 6, end at 7 with respect to dt. For my class and on the AP exam, you don't have to write out the entire function if they've named it. Like it's going to save you a whole lot of time just to say E of t instead of writing out the 144 minus t squared times e to the sine of t. You can, but they give it to you as a name. You can just give it the name. It does ask us to find these, so I did want to review how we use our calculator. So we are going to round this to the nearest whole number. The units of measurement are going to be people. To get this into the calculator, again, make sure you are in radians. And then math 9 for most of your calculators is going to how you get to that menu. Yeah, go ahead if you have a question. I just see a yellow hand.
Yeah, I was just gonna say let's just say at the at e equals 6, there was like a number. Would you add that to your integral?
So this one, a good question. This one would not have an initial condition in front of it. So there's a difference between asking how many people are in the haunted house at t is equal to 7, and then how many people have just entered the haunted house between t is equal to 6 and t is equal to 7.
Okay,
So this one, we're not including any initial conditions. We just want to know what's happening between the interval, not up until a certain value.
got you. Thank you.
You're welcome. So again, I'm just going to go ahead and type this in, and then let the calculator do the work for me. Normally on the AP exam, you always round to 3 decimal places, but this one is just asking us to round to the nearest whole number, so that's what we will do. And again, your calculator has to be in radians to get the right answer.
Mr. Brown,
Yes.
can I borrow a vacuum calculator?
Yeah, they're up here. And then enter. So we can basically see between the hours of t is equal to 6 and t is equal to 7, so 6 p.m. to 7 p.m., 128.413 people have entered. It does tell us to round to the nearest whole number. Let's see if I can fit this all on the same screen. There we go. So the answer we just put down, nearest whole number, 128 people. And that is the work they would expect you to show on the AP exam. Same thing for like my test. You have to show the setup, like where the answer came from, and then your answer. Questions on part A?
Where do you get a T?
Use X instead. Sorry, I should have said that more clear. So just use X when you're using it in the calculator instead of T. No one knows what you're actually typing in the calculator anyways. So then looking at part B, again, we want to show the setup and like our final answer. So it says at 9 p.m., so no longer are we dealing with an interval. At 9 p.m., is the number of people inside the haunted house increasing or is the number of people decreasing? And then we do want to make sure we give a reason for our answer. So if we're looking at this one, again, certain things I notice. Part B is asking for at a certain value, so like we no longer have an interval, just at t is equal to 9. When we talk about something increasing or decreasing in calculus, again, let's connect this to the things we already know. Often when talking about increasing or decreasing, we're talking about like the derivative. We know like a positive first derivative means the function is increasing. A first derivative means the function is decreasing. We kind of already are dealing with derivatives since that function is representing a rate. E of t is the rate that people are entering the haunted house. 110 is the rate that people are leaving the haunted house. 2 ways that we can approach part B. One way that I think more students kind of look at is you can compare the rate in and the rate going out. And I think that's how most students would see it. Most of you will probably see it that way. Well, what's going to be the rate going in? That's going to be whatever E of 9 is. And again, I can just evaluate that in my calculator. What is the rate out that was given to us? At t equals 9, the rate was constant, so we didn't have to plug it in. It was a constant rate out of 110 people per hour. And then I can just go ahead and use my calculator to evaluate E of 9. So I have 144 minus 9 squared times e to the sine of 9 which gives me 95.131. I know those of you in person, that calculator screen, it's probably pretty tiny, but we do see that this is 95 points, and again, 3 decimals, I'll say 131, which is less than 110. Well, if the rate of people entering the haunted house is less than the rate of people leaving the haunted house, would that overall number of people inside that haunted house be going up or going down? Going down. So decreasing at t is equal to 9. You would want to be clear if you're showing your work for this one that you were finding E of 9 and comparing it to the 110. The other way to do that problem, I don't think it's the intuitive one, but you basically want to compare the net rate to basically 0, where that net rate would be the rate of people entering minus the rate of people leaving. which in this case is less than 0, so then it would still be the same reason. To me, I just think it's a lot more intuitive to compare the rate in and rate out instead of like this net rate. We often don't think of the real world as like a net rate kind of situation. Questions on part B? All right, part C, and again, we're going to kind of keep relying on the calculator. How many people are inside the haunted house at 10 p.m.? So I do want to compare C to part A. Part A asks us how many entered the haunted house between 6 and 7, compared to part C, which is just saying how many people are inside at 10 p.m. or at T is equal to 10. Part C is going to be the type of problem where we would want to use an initial condition if we have one. I know the initial condition for this one, it does say that at T equals 6, no one is in the haunted house. I'm going to write it down just to remind ourselves that if it was a different number, we would want to include it. So if I'm thinking about this one, we have 0 people in the haunted house originally. At 6 o'clock, the haunted house opens up. We want to know what's happening up until 10. And I want to integrate E of t dt. But if we want to know the total number of people in that haunted house, we also want to subtract off the number of people who are leaving. People do not start leaving the haunted house, it tells us, until t is equal to 7. So people are going to start leaving at 7. Still stopping at 10. What was the rate that people were leaving? It was that constant number of 110 people per hour with respect to dt. And then we just want to use our calculator to kind of figure that out. Yes, Seth?
So do we still need to show that last integral?
So another way to write that one, so you could leave off the 0, of course. Another way to write that one, since that is a constant one, you could write it not as an integral. So if you're starting at 7, ending at 10, that's 3 hours. So people are leaving at 110 people per hour for a time interval of 3, which is the same. So either of those would be the same thing you want to show, and then we'll use our calculator to evaluate it. It does say to round again to the nearest whole number. In my calculator, again, definitely cheat if you can, so you have to type in all of that again. Not going to worry about the initial condition because it's 0, but I'm going to up arrow and select this first integral we have. And I'm going to change it to 6 to 10. So there's the number of people who entered overall just into the haunted house. But people are leaving at a rate of 110 people per hour. They start leaving at 7. We're going up to 10. So that's going to be for 3 hours. And again, I could have done that as an integral as well. But we do see that we have how many people total? 225.529. And I am going to go ahead and round that to the nearest whole number. There are 226 people in the haunted house at 10 p.m. So definitely probably violating some COVID restrictions there. Questions on that? Yeah.
You only should round it if
It will tell you to either round it, or if it doesn't say round it, then always do the 3 decimals.
okay. Oh, okay, it says.
They told you, right? Yeah. Like if you're doing something like these problems dealing with like people or like things that are like discrete values, they're always going to tell you to round it to a whole number. Because technically we have like, I don't know, a little more than half a person's out the door, but not quite there. Part D is going to be the difficult one. I put part D on here because on the first quiz we had, the problem dealing with the candidates test and integral defined functions was terrible, which is understandable. We haven't done a lot with integral defined functions, so I did want to go ahead, review that, because again, there's hardly, I think between 2 classes, there might be like 3 people who got all points on that problem. So definitely want to review candidates test, then also candidates test with these integral defined functions. So let's just read the question first and kind of think about why I'm even going to do a candidates test. But it says at what value of t within the interval from 7 to 12 is the number of people inside the haunted house at a maximum? Big clue that we're doing a candidates test. We are trying to find the maximum number of people. So we are going to want to do like an absolute max, basically. We're going to be doing a candidates test. let's just review from first semester when you had to do a candidates test. Certain things that we have to include on our candidates test. It basically is a T-chart. First mistake I was seeing a lot on that quiz is the two columns are going to be x and then the original function. Some people are using the derivative on their candidates test. The second thing you know on the candidates test is the x values you use are going to be the endpoints and the critical points. And when I say critical points, that's when the derivative is equal to 0 or when the derivative is undefined. This problem is a little bit different because clearly we don't have like an original function to talk about. But we are still going to do a candidates test. So if I'm looking at this problem, we're going to rely on the calculator a lot to do the work for us. We know that we're looking for the maximum number of people in the haunted house. So like this whole situation, this kind of thing was happening. We have this function of people like getting into the haunted house. Then we have this constant rate of people leaving the haunted house. At some point, there's going to be a whole bunch of people in that haunted house where like this equilibrium kind of situation is happening. We can use the calculus of a candidates test to help us figure out where those values are going to occur. I'm going to use a t for that because we want to find the time that this maximum is going to occur at. I'm going to have my end points on that, so starting at 7 and ending at 12. What's the other column? It is kind of like the original function, but what are we trying to find the maximum of? We are trying to find the maximum number of people. So then kind of the tricky part, we want to kind of figure out the critical points for a problem like this. Like it's not a traditional thing where we have like an f of x and we can take the derivative and set it equal to 0. So let's just kind of think about what it means to find a critical point or a critical number. Not going to need to worry about when the derivative is undefined for a problem like this. It's a real life situation, the derivative is always going to be defined. We know critical points occur when the derivative is equal to 0. That's a fact. We learned that first semester. For these problems, we can think of the derivative as a rate. Like that's what the derivative is representing. So we're going to think about it as when the rate is equal to 0. I am going to be a little bit more specific and talk about that's going to be where the net rate is equal to 0. Well, what is the net rate of this situation? It's going to be the rate that people are entering minus the rate that people are leaving, which in this case is a constant. That is the equation you would want to solve in order to help you find your critical points. To make it even more sense, like if I were to solve this one, I'm going to tell you like you can't do this one by hand. We are going to rely on the calculator. I might move that 110 over and set E of t equal to it. In general, for problems like this, and it shows up enough that it's just better to memorize it, the critical points of these type of problem situations are going to occur when the rate n is equal to the rate going out. There's the reason why, like it's still connecting to when the derivative is equal to 0. I like to think of it as kind of like when you reach this like equilibrium point of the rates, that's going to be a potential maximum or minimum of whatever situation you're talking about. So we want to see when that's going to happen. E of t is in that crazy function with like exponentials and trig in it. Like it's not going to be one that we can solve by hand. So we are going to have to actually rely on our calculator to solve it. So in the calculator, I know those of you, I know you use it a lot in like AP Chem, like the solver. We're not going to use that solver option in the calculator because like short answer is like that's fine for some classes when you only have a single solution. In a math class where you have like multiple solutions, solving by graphing is going to be more reliable. And that's what the AP exam is going to expect you to do, is to solve by graphing. They're going to give you usually something that has trig, so it's going to be multiple values technically. So you are going to want to solve by graphing. Don't know if you remember it. I'm going to kind of go through the steps with you right now of how we would solve by graphing. But we'll be doing so much solving by graphing really over the next like 3 units that you'll become like an expert at just like punching into your calculator and relying on your calculator. So let's solve by graphing. First step is to type in the functions into the calculator. So we know that the critical points are going to occur when the rate in is equal to the rate going out. I'm gonna make that a larger display, so there we go. So I typed in E of t into y1, and then I typed in the rate out in y2. Again, sometimes the rate out might be a function, so it wouldn't be just like a number like 110, it could be some other function. And then we want to graph it to see where they intersect. And again, make sure you're always in radians. Zoom 6, we know often gives us a standard window. Not going to be too nice for this one because obviously these values are a lot bigger than on that window, so we're not going to see the intersection points. We do want to be able to see the intersection points when we graph it. So I might use the problem situation to kind of figure out where I need to start and end certain values. So I'm going to hit the window button instead. We are asked to find the maximum value when t is between 7 and 12. I'm going to go ahead and just change my x values to 7 and 12. Because I don't care about any intersection points outside that interval because this situation doesn't happen outside that interval. And then for my min and max, like I'm just going to go ahead and change my minimum value to 0. Like I'm not going to ever have a negative number of people in the haunted house. And for my maximum, the answer we got for that previous problem was like 200 something. I already forgot. 226. So I'm just going to say, I don't know, we'll say 300, something just big. And then I'm going to hit graph. And so we see a function. We'll kind of talk about what we're looking at. The blue line is the rate people are entering the haunted house. And again, not the number of people, but the rate people are entering the haunted house. The red line is the rate that people are exiting the haunted house. Most common mistake, people look at this blue graph, or it's blue on mine, and they look at that peak and they go, well, clearly that's where there's going to be the maximum number of people in the haunted house. But these are rates, you have to kind of think like, this represents the number of people per hour entering. So yes, people are getting like in line, if you will, the fastest there, but that doesn't mean that's when there's the most people inside that haunted house. Like they're still building up in the line all the way up until that equilibrium point that you see. So that kind of intersection point is the critical point. That's where the input and the output rates are equal to each other. So we do want to go ahead and find that intersection point. To find an intersection point, you're going to hit second trace, our second calc along the top, and we want to find the intersection point, so option 5. It's just going to ask you some series of questions, so like, hey, is this your first curve? Yeah, enter. Sure, that's my first curve. Is that my second curve? Yep, that's my second graph, enter. It is going to ask you to guess. Guess is important, especially if you have like multiple intersection points. You have to do this several times. It will also, the closer you are to the intersection point, the faster your calculator is going to calculate it, especially for some of the more complicated functions. So I'm just going to go ahead and scroll close to the intersection point and then hit enter, and it will go ahead and find that intersection point for you. These graphs are intersecting at 8.875, so that's going to be another critical point that we will need to consider. So I'm going to go ahead and add that to my candidates test, open up for questions, and then we'll kind of finish out the problem. If I can find my marker. So we also have, it was 8.875. So questions before we fill out that T-chart from anyone? All right, so let's go ahead and fill it in. One of the biggest mistakes I saw on the quiz was people just kind of using whatever thing they wanted to when finding the value. So like on the quiz, I know it wasn't a word problem situation, but we were just kind of plugging it into the integrand. But remember, like the number of people is an integral, so we're actually going to have to evaluate the integral. So like at 7, let's think about the number of people we have at 7. So we had 0 was the initial condition. People started entering at 6. We're going up to 7 of E of t. Don't need to worry about subtracting people leaving. People didn't start leaving until 7. I'll use my calculator to evaluate that. Then we want to figure out the number of people at that critical point. So we still had the initial condition. People started entering at 6 up until that initial condition. But then we also had people leaving. People started leaving at 7 up until that critical point of 110 dt. That would give us the number of people at the critical point. Then we want to figure out the number of people at midnight. Same thing, initial condition, 6 to 12 of EFT dt minus the integral from 7 to 12 of 110 dt. And I am just going to go ahead and use my calculator to evaluate that. Just to show you some other shortcuts, again, you may choose to do this, you may choose not to do this. But once you graph a function in your calculator, it's actually doing more than just like graphing it. You're saving that function as y1 and y2 in the calculator. So if you don't want to have to type in a whole function again, there are some other shortcuts. One shortcut you can do, so I'm going to go ahead and go back to my home screen. So at t is equal to 7, I have 0 as my initial condition. Math 9. I want to find the number of people from 6 to 7. Instead of typing in EFT again, as long as I've graphed it, my calculator is now calling y1 EFT. And I can actually select y1. And to do that, again, shortcut next to clear, you see a button that says vars, that stands for variable. Select that, and then scroll over to yvars, and then it's a function, and y1 is there. And so now I'm integrating the integral from 6 to 7 of y1. What was y1? That's where I typed in EFT. So you would have to remember, of course, where you typed in each function. That was with respect to x, and then enter. That would be the number of people at t is equal to 7. And I can just kind of keep doing that again for each row. So then I want to figure out how many people I had at the critical point we found. That was 8.875 minus the integral from 7 to 8.875. Not going to go and select y2 because it was just 110. That would be a waste of time. With respect to dx, there's the number of people there at the critical point, the 283. And then I want to do that same thing for midnight. So I'm going to go up and select that option and change my upper limits of integration to 12. And we see that there's only 25 people left in the haunted house at midnight, which is good because that's probably near closing. So if we were going to answer this question, I'm going to be lazy and not type in all those numbers. When are we going to say that the maximum number of people are in the haunted house? Well, the maximum number of people are going to be in the haunted house at that critical point we found. And the reasoning would, of course, be C candidates test. So it's going to be at t is equal to 8.75, 8.875, C candidates test. A lot going on in that problem. Don't want to scare anyone, but like that whole problem, parts A through D, would normally be something that you would want to spend probably about 15 minutes on if it was the actual AP exam. That's about how fast you would want to work. Again, with practice, I think most of you could do that in 15 minutes. I think the most complicated part is just like punching it all into your calculator to get to the answers. Questions, though, on any of those that you want me to go back and explain a little bit better?
Why does the rate not have a variable with it? Like, why is it at 110x?
So you have to, like, the short answer is because that's just what they told me the rate was. So like when they say EFT up here, like that whole function, that is the rate. Like it's not a constant rate, it's changing as a variable in it. Down here, like we don't have a variable on it because it's just telling us that 110 is the rate. Like if it wanted to, like it could have given you a function like maybe it would say like L of t is equal to 110. when you put that variable on it, like 110T, you're turning it in from a rate to basically an amount. So like why doesn't have a variable on it? And the short answer is like, because they told us it was a constant rate. Yeah, they even emphasized it was a constant rate, so it was just gonna be 110.
Okay. Thank you.
Yeah,
So number for B and C, they're both asking for, like B is asking for the number of people inside, but you didn't use the integral, so I'm kind of.
so you have to be careful. So C is asking for how many, so it is asking for the number of people, so that's why we had the integral. B though is technically not asking for the number of people, it's asking for is the number increasing or decreasing. So it really was asking for, in many ways, like a rate and not the number of people in there at the time.
Is there a way you could do it, so like you actually do find it?
Like if you found the integral, it wouldn't tell you anything. Like you would just say like, oh, there's 200 people in the haunted house at 9 o'clock. And you're like, I don't know if that's going up or going down. So you would have to use the rate equations to figure that out. Any other questions on that one? All right, again, like promise you, your AP exam is gonna have a question like that, probably question 1 or 2. I know it is kind of a harder topic. They can ask you all sorts of crazy applications that you may or may not be used to. The assignment that I want you working on, again, it's just to kind of continue working on the homework. First thing that I want you to do is, of course, homework 4 part A. That's going to be the basics. You really can't do the word problems until you get the basics down. Doing second, I want you to go ahead and work on part B, and that's where you're going to be the free responses.